In this video, we're going to review factoring. If you already have a method that works, that's fine. You just need to be able to factor quickly. A lot of times the box method, the diamond, whatever method you use is not a quick way to factor. Plus, we don't always have numbers. A lot of times we'll just have variables. So we do need to understand what it is. But factor means divide. So when we're factoring, we're taking the problem and we're splitting it up into a multiplication problem. So a reverse example is when we have two factors. If we FOIL, here we would get 3x squared, minus 3x, plus 2x minus 2. And then combining like terms, we would get minus x, and then we drop the other terms down. So what we're given when we're factoring is the simplified version, and we're asked to go back up to this step. So we've got to first get to this step, and then go that step further. And if you use like a diamond method or whatever, again, it just takes longer. Hopefully, we kind of want to get to the point where we can just skip all this and go straight to this piece here. So we're looking for pairs of factors of A and B. So we're always starting by looking at factors of these guys. If this is 1, we really don't need to mess with it. But once we find those factors, then we're just kind of plugging and chugging. We know we're writing this as a product, so we can usually fill that in right away. This method works for quadratics, so we know we need to have x times x so that we get that x squared. And then if this guy only has factors of 1, ignore it. Otherwise, we look at the factors of that guy. We fill them in. This symbol tells us that the signs are going to be the same because two signs that are the same multiply to be a positive. And then that sign tells us what they'll be. So in this case, they're both positive. So it's a lot quicker than using any other kind of method. So again, when this is positive, that tells us the signs are the same. That first sign tells you what they'll be. If it's negative, your signs are different. So if there's more than 2 factors of A, we do have a little bit more work, but hopefully as you get going, it'll be a little bit easier. So the factors of 2 are just 2 and 1. The factors of 30 are 1 and 30, 2, 15, 3, 10, and 5, 6. And we're trying to pair these up with one of these pairs in order to make 7. And so hopefully by looking, we can kind of see here that if we pair these together, we get, we don't want to pair those together. We want to pair the 2 of the 6. So there we get 12. And then if we pair these together, we get 5. 12 and 5 can subtract to 7. So still have a product. Whatever your first pair of factors is, that's how we get this first term. So those have to go in the first 2 spots. So I'm going to say 2n and 1n. And then we need to figure out where the 5 and the 6 goes. Well, we know the 5 needs to be multiplied by the 1. So they have to go in opposite parentheses so they end up getting multiplied. So we have our 5, our 6 goes in our remaining spot. Again, these need to be in opposite parentheses because we need to multiply them to 12. This guy tells me different signs. So I just need to figure out how to make this so that we get a positive 7. And if we do 12 minus 5, we get positive 7. So I need my 12 to be positive. So 6 times positive 2. I need my 5 to be negative. Negative 5 times 1n. So this is factored. And the more you do this, the less you're going to have to go through that entire thought process. So here we have bigger numbers. Anytime your numbers are really big, always kind of double check for GCF. That can definitely save you a lot of time and make the problem a lot. So if we factor out the GCF of 3 and we write out our pairs of factors, just remember this GCF just kind of hangs out the whole time. On looking at this, we should hopefully see that we're going to look at these pairs because we can pair the 2 and the 4 to make 8. And here we have 3, and 8 minus 3 is 5. So I'm going to take this first pair of factors, I'm going to fill them in. Second pair of factors, again, I wanted 8 minus 5, so to make 8, I need 4 times 2. And I want that to be a positive 8. So my 2 went here, my 3 then needs to go in that parenthesis. So this guy is completely factored. Okay, now we're going to move into simplifying rational expressions. Just be very careful. I tend to see a lot of people do this. Just be careful. This is part of an addition problem, and this says divide. And addition and division have completely different rules. For any kind of problem, they have totally different rules. We can only divide if it's a factor, if it's being multiplied. So an example here is if we did this, we would get 3x. Well, if we choose a sample value of x, let's say x equals 1, and plug it into the original, we would get 5 times 1 plus 3 times 1 all over 5 times 1, or 8/5. If we plug 1 into what we thought was the answer, we get 3, and those are not equivalent. So just be careful, we can't do that. What we can do, however, is factor first. So remember, terms are things that are being added and subtracted. We cannot divide any of those. What we can divide, however, are things that are being multiplied. So here, nothing can be divided. That's what this means. So we do need a factor. We're going to factor out a 6b. Factor means divide, so we're going to divide it out. And in the denominator, then, this is already written as the product, so that's already a factor. Now, because this is multiplication, this is division, I can divide these because this is being multiplied. And PEMDAS says I can do multiplication and division in any order. That's why I'm allowed to do this. So if we simplify here, we'll get 4 on the bottom. The b's can cancel, and this factor is still left over in the numerator. Okay, one more example. Again, this does need to be in factor form. So my first 2 terms are n's. My last 2 are going to be 7 and 5. We're going to have a -7 and a +5 to make that -2. In the denominator, we're going to factor out a 3. And now, because this is one number being multiplied by 3, and this is one number being multiplied by n minus 7, I can divide the 2. And I'm left with n minus